For transformations, this is already filled out for you. So whenever I have a function, I can have all of these transformations. So in total, it's 1, 2, 3, 4, 5, 6 transformations in total. Normally in this class, we have 4 typical ones. We don't really see a reflection on the y-axis as much, or horizontal stretch or shrink. But everything else we do see. Go ahead and take a minute to pause the video and look and read everything that's on here for a little bit. Hopefully you paused it and you read some stuff. Otherwise, you might be a little confused and trying to keep up. The first negative is a reflection on the x-axis. So here's what I want you to do. You should be on your Chromebook or whatever. So I need you to open up a tab and go to decimals and type in f of x equals absolute value of x on the first line. On the second line, I need f of x equals, and then we're going to type in that negative right after the equal sign. So negative absolute value of x, and compare the graphs. You're going to notice that the parent function looks like this. And the new one is reflected on the x-axis. X-axis means it flipped over like that. So that's what a reflection on the x-axis looks like. And then you can try that for all the transformations we have here. So for example, if you want to try A, which is a vertical stretch or shrink, if the number is greater than 1, so for example, if A is 2, so I have 2 absolute value of x, then that means I have a vertical stretch. So your original graph looks like that. The vertical stretch looks a little more narrow. Narrow because whenever you stretch out, your stomach gets like sinks in, so you look skinnier. So we say that A, whenever you stretch it, we have a narrow graph. Whenever you shrink it, we have a wider graph. It looks more chubby because you're squishing it down. And then you can take away the 2 and then type in a negative instead of the absolute value. That's going to be a reflection on the y-axis, which doesn't look like anything because your graph just flips from side to side. And again, you can erase that number again and then type the number on the inside to see what this looks like and try all of it. For example, if I want to try a translation to the left, that's when I add a number after the x. So if I want to translate, I have f of x equals absolute value of x, and then after the x, I'm going to add a number and compare that to the parent function. You should see that the parent function goes at the origin, and the new one is going to be translated to the left a few, so something like that. The parent one goes on the origin, and the new one is going to be translated to the left. So again, you can try different transformations. I'm going to try a little bit in a few in a little bit, but first, here's what I want to check first. How can you recognize the transformations by just reading the numbers on my formula? So for example, if A equals 2, this is my A. If A is 2, is that greater than 1 or less than 1? Well, I know it's greater than 1. So since my A value is 2, my first transformation is a vertical stretch by 2. So it's a vertical stretch by 2. My next number is the h. Notice I highlighted it. I am adding a number. If I add a number, I translate at left. So my second transformation is to translate left by 1. My h, however, see how I have a plus 1? Even though I have a plus 1, your h is always the opposite. It's horizontal, it's on the inside, and it's always the opposite. So these numbers always lie. Instead of parentheses, we lie. So even though I have a plus 1, it's really going to be a minus 1. Now my last transformation is my k. My k is honest just like the a. My k is a minus 3, so whenever I have a minus 3 all the way at the end, it means I'm translating down. So I am going to translate down by 3. So here is what's going on. On my graph, my parent function looked like that, kind of. Now I vertically stretch by 2. Vertically stretch means that I made my graph a little bit more narrow. Then I translate it to the left by 1. So I moved my graph to the left 1. And then I translate it down by 3. So I moved my graph from that blue one down 3. So like this. So again, that's my final product. So from the beginning, here's my parent. My final product now looks like skinnier on the left and down. That's what we're looking at. Those are the 3 transformations. This is my new graph, and that graph belongs to that equation. My vertex here, this is my vertex. My vertex is h comma k. So for this problem, my vertex is -1 comma -3. Let's do another one real quick. My a value comes from right here. Right now it's a 1. Since it's not greater than 1 or less than 1, that means I basically didn't transform anything there. So that's not a really transformation. Nothing happened. But something did happen at my -5. That's going to be my first transformation. At the -5, because I'm subtracting it, that means I went to the right side. So right 5 units, but the h's lie. So my h is really a +5, even though it looks like a -5. My second transformation comes from the k, which is a +7. Since I'm adding something, I really went up. So that +7 tells me that I went up 7 units. So again, we're going to start from the parent function. We're going to go to the right 5 units. And then we're going to go up 7 units. So that means here's my parent. And here's my new. Always go from the parent to the new function. My vertex for this one is h comma k. Notice that your axis of symmetry will always cut down on your vertex because you always cut your graph in half. So your axis of symmetry is going to be x equals 5 for this one. And axis of symmetry is x -1 for that one.